Okay. That's better. That is better. I'm going to say, I don't care what you say, that's a little bit bigger and a little bit easier to read, right? The MTS, will you give me, thank God, somebody. Bryce, a little bigger, a little better? Yep. Okay, so this little button right here, looks like a little cloud on it, right? You should be able to click on that, right? And then that will bring up your cloud drive, and then also make that probably your current directory when you click on that, right? And then I have little subfolders within that. You could create all these folders. What's really nice is if you store it on there, if you open up MATLAB and log in on a Windows like the Tate Lab computer, all your files will be there. It's a cloud storage, right? Or if you open it up on your iPad, it'll be there. Or if you open it up on Safari, it'll be there. So it's nice to have them in the cloud, right? And then many times students have like put them on little flash drives. You guys don't still use flash drives, do you? You do. Yeah, and then you lose it. That used to be a big thing. And then you lose it. It's a very common thing students do for years is they put it into the Tate Lab computer and then they leave, and they leave it in the Tate Lab, and their whole career is on that little teeny thing, and then they lose it, and it's panic. Now everything's in the cloud. But anyways, so that's the current directory, and then that's the MATLAB drive. And so again, set that thing up, make sure that it's working. I think by default, it's not installed. So when you click that little button, it'll say, hold on a second, I need to install it, and then it installs it, and then it should be blank for you. And then you can, again, make a bunch of like subfolders in there, and then kind of go that route. Okay. That is the current directory. And then so sometimes if you're not in the current directory, if it hasn't been saved, so if I'm in this editor and I go to run it, we have, again, you'll get better at this, but like I make this code and I have to tell it to run. Like it doesn't automatically run unless I tell it to run. There's this little command up here under editor that says run. And so if I hit run, right, it'll evaluate it. Okay, it'll actually go through and carry out that code. Sometimes it'll kick it back at you because if the file you're working on isn't in the current directory, it'll say, hey, this file's not in the current directory, I can't do anything about it. And then it'll give you a prompt that says, do you want to change directories? Let me show you an example. So let me see. I think this will work. Can I come back? I make 315, and I try to run this, it should tell me. Oh, it did not. Oh, because it's a live one. Anyways, just be careful. You'll get a prompt. Sometimes if you hit it, you'll get this little prompt that says, hey, I can't do this. I really wanted to show you that. Let me see. And then I'm going to make a current directory something else. Right, and if I try to run this, it should, yeah, see, this is it. So I'm not in the current directory. So if you get this little warning, that's what it's telling you. It says, hey, the file you're trying to run isn't in the current directory. And then it'll give you a prompt that says, do you want to change it? And so that's easy to do. You just say change the folder, and then it'll go through and it'll change that folder. There's another example of my unlimited power. To demonstrate some Structures 2 stuff. It demonstrates concrete beam bending. I use it in Structures 2 when I've taught it before. Yeah. You guys all took Structures 2, right? Yeah. So like when so you could change the concrete strength and the width and the depth of it, and it calculates the moment capacity of a beam. And you could talk about like, because you start out with no load and you can start increasing the. Oh, you used to be able to. Yep. You start increasing the load as it goes along. And then eventually, you can see that this is what the steel's doing. You can see if the steel is yielding or not. Right? You gotta demonstrate that. And that's ACI concrete, but you could also do nonlinear. And so you have this little thing right here. You can include tension or not. Right? So you have a little bit of tension in there. Right? You remember 315? Back in the day. And then like, remember you talked about over reinforced or under reinforced beams? Like if you get over reinforced, if you put too much steel in it. So if I put in, make this 15 inches of steel, right? And so then you can see if I do that, then my steel doesn't yield at failure, right? So you can kind of, yeah, because the T gets really big, so then the C has to get really big, which means the neutral axis moves down, which means this is my little demonstration for it. Again, try to do that in Excel. Can't do it. Well, is that what you said?
Yeah, that's what I'm going to say to my mom.
Say, you think you're...
Excel.
Yeah.
Can Excel do this?
And the answer is no.
No.
Yeah.
And then send her the file from Gunner.
Yeah, Gunner. Yeah, try to run this. Try to run this with you.
This
Pew.
is Excel mom.
Pew. I mean, I will say, Excel behind the scenes, there's a programming language. I don't know if you're aware of this. It's called Visual Basic, is what it's called, and you can actually program in Excel to do a bunch of stuff, right? And what's interesting is like the for loops and while loops and things like that we'll learn in here. It has it. It's just a different way of implementing it. And what's nice about it is it is built into Excel. So if it's free, right? Like MATLAB isn't free. Like you go in the real world, you're not gonna have access to MATLAB unless you work at a cool place. So I think I covered all that. MATLAB Drive is cloud-based storage. Once you've logged in, you can access MATLAB Drive. You can all access MATLAB Drive files from MATLAB mobile app or through the web. I think you get a mobile app for your phone. You can be running MATLAB from your phone if you wanted to. Huh, Kyle?
I'll have to look into that.
Yeah.
Are you texting?
I'm coding. I'm coding. Now, again, this is like fire hose. I'm throwing all sorts of stuff at you. Once you start actually programming, you'll probably think like this something doesn't work. You'll be like, oh, I remember Mike said something about this before. That's my goal right now. Or you'll be like, I don't know what's happening, and then I'll be, remember when I told you that? You're like, no, I don't. But so another thing you could do within MATLAB, you can create what they call cells. So instead of running the whole, by default, what this used to be when I first started coding, that's all I could do, is I could just run the entire thing. And by running the entire thing, I mean I'd hit this little run thing, and then everything in that editor file would run. And so it would run the entire script. Sometimes you don't want to run the entire script. Like maybe you get problem 1 is working really well, and then you have problem 2 down below, and I don't want to rerun problem 1, or if I change a variable name or something like that between 1 and 2, you just want to keep them compartmentalized. And so MATLAB lets you do this. This is, again, something new since I first started programming, is you just put it, what you do is you put a %, and then call it like problem 1. And then you hit return. And then it breaks it up, and then it'll run that little cell independent of the next part. And so I do the same thing, %, problem 2, right? And I hit enter, and then it creates problem 2 right below it. And then I can compartmentalize it. If I just want to run problem 1 and not problem 2, right up here, it says run section, right? And that's what I do. I run section, it would just run that little part, or problem 2, I just run that little part. The other thing you could do, and you should learn how to do these things, are the shortcuts. See the little shortcut that shows up there when I put it out there? It says hold the circly button and the return, right? What is that button called? Command. Hold the command button down and hit enter, and then it'll just run this one, right? And so if say this is x equals 7, right? Y is equal to 10, right? And then if I just want to run the top one, I just do that. If I want to run just the next one, I just hit the command window in that, and I just run sections. It's really nice to be able to compartmentalize, especially when you're putting together, like if you have a whole bunch of problems that you're putting in one script instead of having a separate script for every problem, homework problem. Just put them all in one place and just separate them by this. There's other ways to do it in a live script. This is the live script that I'm doing. The %'s the easiest way to do it, but I think that there's probably a section break right here. Yep, section break did it. And then you can put a title. You can put titles and stuff like that in there. And like I said, you can even bring in like PDFs and put them in there as well in the live script. If you do it in a .m file, this is a .m file. What it looks like, it looks slightly different. %, problem 1. And then I do that here. %, problem. Right. And so then it breaks it up like that. It doesn't make it as pretty where it has like, different text or different fonts and stuff like that. It just does that. But then you can keep it separate and run them that way as well. Okay. Which also brings up a good point. I think one of the later topics in this editor, right? And we're gonna in specifics on actually how you do the coding stuff. But like a equals 5, x equals 7, obviously takes 5 and puts it in a, and then takes 7 and puts it in x. But if for some reason you want to change it, as like I don't want to run this anymore, you just put 1% sign in front of it. That's called commenting stuff out. And if you put the % sign there, you notice it all turns green. And when it all turns green, it means don't do that. right? Just look at it. It exists there, but it just don't do it, right? And it actually is really good if you're a good coder, you'll comment your code. You'll say like, oh, x equals 7. It's like initializing variables, and I'll do that. And actually, I hate to say this, but I think MATLAB comments all, or ChatGPT comments all of its code. Yeah, see? Right? So that's what that first percent is. Coefficient matrix. A is equal to this. Next one, right-hand side vector, solve for x, display solution, verify solution. So it puts the comments in there. If you're a good coder, you'll have that, because especially when things get really complicated, you want to be able to look back and say, like, what did I do there, right? During, like I said, most of my PhD was coding, doing all sorts of fun coding stuff. And I look back at some of my code, and a common thing that happens in coding is you make it work, and then you make it work better. That's a common thing to do. Well, near the end of my PhD, I just made it work, and it was just hokey and thrown together and just mashed up. And if I ever tried it, a few years ago, I tried getting an extra paper out of my PhD, and it was impossible because I couldn't understand my code that I had written. I didn't comment anything and stuff like that. So it's a.
Put it in ChatGPT.
I should. Except for again, it's very complicated. So it might be able to do it. It might just be like, what the, I don't. You should be ashamed of yourself. That's what it would say to me. Is you should be ashamed of yourself. Yeah.
Do you want us to comment?
I,
See what we're doing?
you know, Kayla, it's good practice, but I don't ever do it. Just like if you remember in all my classes, units. Who fucking cares about units?
Are you kidding me?
Oh yeah. I have been so loose with units, right? It's a bad practice,
That's
but
a
I am.
really bad
Oh, it's
practice.
so bad, especially when you're trying to teach sophomores how to do engineering, and you're just like, just kind of guess if these are the right units. I know, but it takes so long.
For dynamics?
Oh, it takes so long to write units down. Oh my God.
No, it doesn't.
Right, it's so boring.
Do you ever do unit conversions?
Yeah. To get it into the right units, and then you plug them all in the same units, and just hope they're right. Hey, listen.
Actually, we didn't get that far. We just had to write out the equation and then make the computer answer.
I just want to say, I have made it this far in my career, being super loose with my units. I will not change myself, right? Like, I'm a doctor. I've been a doctor, full professor doctor for 20 years, and I never use units.
What career?
Oh, well, Bryce.
You're not even
That's too bad. Bryce isn't gonna make it through this class. Motherfucker. This is a career. It's.
3 work days a week.
Hey. I had to work my way to this. That was an automatic.
Speaking of, guys, he's got a PhD.
Are we
Yeah, I'm a doctor.
Are we taking class off Friday next week, even though we don't have class Monday?
Yes. Absolutely. What about animals? God, absolutely we are. Just don't tell Tim. Don't tell Timothy. I don't want him coming back after me. Tim and I got a big argument about which was harder to get, a PE or a PhD.
Probably PE.
No,
That's
I-
wrong.
No,
That's
I think a PhD.
It's a PhD.
I think an SC.
Yeah,
Oh, sure.
that one.
SE, sure.
But
Sure.
I
But the
think
PhD, it's
freaking
4 to
hard.
5 years of just
Could be
open-ended. You do whatever you want, and then just at some point have motivation enough to finish it. And it takes forever, and you get paid like shit. And then and then you got these fucking faculty that treat you like shit and make you come in and do stuff all the time. Is that right? And then
You take on fellowships and have to do more work so
yeah,
you can actually get paid more
and
money.
then I don't help out at all, right? I mean, it's very difficult. So Tim and I got a big argument. We had a conversation with ChatGPT, and she wouldn't give me an answer. She was just like, "Well, they're both really hard, and you both should be proud of yourselves," and all this stuff. And I was like, "Yeah." And then I got to a point. I said, "All right, gun to your head, which one's harder?" ChatGPT came back and said the PhD was harder. Just saying. But then Tim also is an SE, so then he beats me with that. But I would like to get the PE. Then I'd have a PhD PE. But also I don't want to study for it and take it. Then what's that? I meet that requirement. Every new class you teach counts as like a year. Like I actually submitted. I was going to take it, and I submitted all the paperwork, and I was scheduled to take it, and I didn't have time to study for it. So I was like, "Can I push it back?" And they're like, "Sure." And then it was like, "Can I push it back again and again?" And it happened for like 4 years, and they're like, "That's enough. Just you're not doing it. Like it's okay."
I bet you could take it.
The scary part is this: is that my undergraduate degree was in math. And then I took the basics, engineering mechanics, and then I went right into structural engineering. I've never taken poop and pee engineering. I've never taken geotech. I've never taken transportation. I've never taken any. Oh yeah, we have an environmental in here. I'm so sorry. I said, plug your ears when I say this stuff, right?
No, it's not wrong.
Yeah. But I don't think I could do it. I don't know that stuff.
That's the
PE
essence.
specialist.
Yeah.
Specialized.
But isn't there like in the morning like a broad like everything?
But that's like ethics and like general like code.
Ooh,
and city and
ethics.
stuff like that. There's no
Okay.
calculation.
Okay. I'll look into it. I'll look
Make
into
you
it.
do structure calcs in the second half.
You
Okay.
just do it despite Tim.
I don't. That's the main reason I want to do it.
You can
It's just.
study on Fridays from 3 to 4.
I could study on Fridays from 3 to 4. I could study Fridays from 3 to 4.
You gotta sit in on Gabriel's geotech. Just start sitting in on all the classes.
Yeah. Geotech.
You have to read it.
Fucking geotech. We've talked about this. This is geotech right here. Spit on it. Spit on it. Yeah, I don't know. What do you think? What do you think?
Isn't this more like structural since it's not on site?
Yeah, but it was outside. If I was outside and I was on the ground and I just, hey, I don't know. What do you think that can hold? I don't know. Maybe I was like 50 PSF. Yeah, that sounds about right. What's it made of? I don't. Yeah, that's about it, right? Okay.
And you call them and you're like, hey, I need
I need proper.
5 KSF instead of 3. Is that okay? Yeah.
Yeah, sure. You have factor safety like 10 in there anyway. But yeah, so the cells in it, right? There's cells and there's a cell, right? And then the plotting. The one thing about plotting, they'll pop up in its own window if you plot it there. Otherwise, it shows up on the right like this, right? The plots show up over on the right. Or they can show up right below, depending on if I click one of these buttons over here. So those things. Publishing. So that's the other thing. If you write a .m file, this was a really cool tool a while ago, but with a .mlx file, it's not as needed as much, but there's an option to publish. So if you have a .m file, there should be this. I'm recording this and I'll post it afterwards. So if you go to work on it later, but there's this publish right here, and it'll make a PDF. It'll run your code. It'll show what the code is, and then right below it in a PDF, it'll put the output, and it'll even make. If you use these like subheadings, like these different cells, it'll even set it up so that those are clickable links. It'll give you a table of contents and you can click on it and it'll bring it down. So the publishing works really well for the .m's, but with the .mlx's now, like the live scripts, they're not needed as much, but just know that they do exist and you can mess with it. But that's kind of nice. I mean, this is what the output would look like. That gives you little sections of code and then what the output would look like right below it. And I don't think you publish the other ones. The other thing that's just a little foreshadowing stuff is MATLAB is really good at finding errors, right? Well, obviously, if there's an error, it's not going to work. But what it's really good at doing is pointing you to the error, right? And so if you mess something up, right? So there's an example right here, and we'll get into this a little bit later. But if I have x as a vector, and then what it tries to do when I just try to run a variable or run an operation on a variable, on a matrix or on a vector, it tries to do matrix math by default. And so it tries to square a 1 by rows columns, a 1 by 3 by a 1 by 3, and you can't multiply a 1 by 3 by 1 by 3 because the inner matrix dimensions, you remember that the inner matrix dimensions don't agree, so you can't do it. So that you can't do it like that. And so what it does is that's an error. And so if you look down below, the output will tell you. It says, hey, error using the caret symbol. Incorrect dimensions for raising a matrix to a power. Check that the matrix is square and that the power is scalar. To operate each element, it tells you what it is. Also, these are links, right? So these are clickable links, live links. If I click on it, it will take me to line 19. This is a screenshot of it, but it would take me to line 19 and show me exactly where the problem is. So use this as a tool. So many times people come into my office just like, I don't know, this thing isn't working. Well, it fucking tells you right there why it's not working in big bright red letters with a little button that you can click that takes you right to it. So So be wary of that. Use those error codes as much as possible. Right? It'll tell you what the problem is. Oh, I was going to tell you something else about that. Error codes. Da-da-da. Oh, so what they used to do, not to, well, back in the day, the way you used to computer program is you had these little punch cards. This is hard for you to believe, but it's even before my time, right? They had these little punch cards. This is like Jerry Stevens, Dan Van Lushen, when they were at Ted Lang. They had these little punch cards. And so you would take this little punch and you'd punch out different things, and that was how you coded. I don't understand how the punch card works, but you'd punch out little things, and then to run the code, you would have to walk over to where the computer was at. The computer at MSU was over in Renee Library, and so you would have to, they had a computing center. So you would bring and there's usually a stack of punch cards, and you'd walk over there with your stack of punch cards, and you would hand them to the computer guy, and he would say, all right, I'll run these tonight. And then he would take those, and he would go over to the computer, and he would run through them that night, and then hopefully you didn't have any errors in your code, because if you did, then he would give them back to you the next day and say, right around here it stopped running, and they'd give you back your punch cards, and then you would then have to go, figure out what you did wrong, and then fix it and bring it back to him and give it to him, and then they would run it each time. Now, within seconds, I just run it, didn't work, run it, didn't work, run it, didn't work, right? And they just and fix it, and they tell you an error tells you exactly where it was. So just be grateful you didn't live back then. Also, then they had, they also, for reals, just in general, just thank goodness we didn't live way back, a hot shower that you get every night. Right? Or every morning, right? This is things we take for granted, right? You go back 100 years, you weren't getting a freaking hot shower, right? You weren't being able to walk into a grocery store and just buy whatever you want, all the spices and all the shit that we have. What a wonderful time we live in. Oranges in Montana, right? What a delicacy, right? We live like king. We literally live like kings, right? We do. It's pretty fucking great, right? It's supposed to be 10 below tonight. I don't give a shit, right? I don't have to survive. I have a big wood stove. I'm gonna have that thing chock full of wood. It's gonna be about 90 degrees in my living room, right? It'll be colder everywhere else, but it's gonna be really free. It's sick, right? And I don't have to worry about living. I don't have to worry about surviving. It's so sick. And computer programming, way easier, right? But then, I'm serious though, right? Right? I'm hopping in my car, right? My biggest problem is I live so close to campus that my heated seats don't have time to heat up between my house and my work. Sometimes I just drive around a little extra just so that my seats heat up a little bit, You know what I'm talking about, right, Bryce? Huh?
I do.
Yeah.
I don't have heated seats.
Yeah. Right? And then just as I pull in, my windshield defrosts. I don't have my head down like this, driving the so sick. So error codes. Oh, so then they advanced to this thing where you could take your punch card, and you had a little machine on your desk, and then you could feed it the punch cards, and then it would call over to the Renee Library, and it would run your code over the Renee Library, and then you have to go back and pick up your output from it and stuff. That was a big advancement. Okay, so a couple more things. Commenting we talked about, and the last thing is clearing stuff, right? So just by default, right, over here, look at this workspace. These are all the variables that are currently defined in this workspace. And so if I came over here and I said, what's D? It should tell me what D is, right? So D is a variable. D totes is a variable. D totes. Right? It has a value, everything over here. Well, sometimes you want to clear those because you don't want all these variables that are defined. You may accidentally reuse a variable but not clear it, and then your code runs wrong and stuff. And so guess what the command for clearing everything is? Clear. Right? So I clear. And by default, clears the entire workspace. You don't have to say just one variable. If I just wanted to clear one variable, right? If I said A is equal to 7 and B is equal to 2, right? And then so that, right, if I say clear A, it'll just clear A, and then leaves B. But if you just do clear without anything there, it clears everything. So great question. I was just gonna get that. So this is my command window. Look at all the shit that's in my command window, right? If you ever want to clear your command window, TLC, and then it just Clear command window. Maybe that's what CLC stands for. Clear command window. The other thing that will happen to you, I don't think I have this in these notes. You will create an infinite loop. Okay? And your computer doesn't know that it's created an infinite loop. And so what's it going to do? Oh, you're going to keep going forever and ever. Right? Forever and ever, it'll just keep going. Very common place that happens is in a while loop. Right? Is a while loop gets going, and then it's just nothing gets incremented, and it'll never be true. Like a while loop will kick you out when something's true or false, depending on how you set it up, and it'll just keep going on forever and ever. If you ever find yourself even in an infinite loop, or even just a code that's taken too long to run, you hit Control C, and that's the same thing on a Mac, and it's the same as on a Windows computer. It's Control C, not Command C. Like, copy paste on a Mac is Command C, but it has to be Control C to break out of it, and that'll save you a lot of problems in the future, because you'll just keep running, and you're like, what do I do? And this Control C just says break, get out, quit. We have a problem. Control C.
You do that.
Yep, exactly. Usually I'm just like this. Control C, Control C, Control C, Control C, because sometimes it takes a while for it to register, because it's doing so many calculations, thousands and thousands of calculations. Right? The other thing you'll see is just, hopefully you'll get out of this class, how incredibly powerful computers are, right? And we looked at that a little bit in structural dynamics, like millions of calculations per second, right? It is so cool at what they've become these days, right? And we mainly use them for playing video games. Yeah. I mean, that's a big one. Cool. What are we doing at time? Also, Bryce, we will not go extra today either.
Wow.
Yeah.
So benevolent.
Yeah.
How kind of
That's a big word. That's a big word. What does it mean? Just
like gracious. but
Gracious.
From like a higher power.
oh yeah, okay. Benevolent. Yeah, I like that.
I assume we're pulling that out to Tim. We call Tim malevolent.
Malevolent. I'm benevolent and he's malevolent.
Benevolent.
Where's malevolent? That's
That's Maleficent.
Maleficent. Tim is Maleficent and I'm benevolent. Is that correct?
No.
Maleficent is evil, right? Maleficent.
It's the name of the.
Yeah, but it does have a word.
Cinderella.
For Cinderella.
No, she's from Sleeping Beauty.
Is that her name? She's not named after something?
Her name's just Maleficent.
Maleficent, but malevolent is an actual attribute, which is evil.
I don't know how to spell it. Maleficent.
M-A-L.
The character of Disney movies, the films themselves, Maleficent. And what is it, malevolent? What is malevolent?
M-A-L.
Okay. Got it?
V-O-L-E-N-T.
Yeah, that's Tim. That's Timothy right there. That's fucking Timothy. Malevolent. We're showing a wish to do harm on others. What was yours? Benevolent. Huh? Close enough. It'll get it. That's what's great about ChatGPT. It doesn't matter. Well-meaning and kindly. Oh, this is great.
Good for others.
Huh? That's great. That's very close to each other and also very true. Tim is malevolent and I'm benevolent. Benevolent, dude. Cool. All right, break.